blackboard for anyone who uses their phone, falls asleep, or needs another look at it. All right? So let's not have to watch it at home, and let's make it a choice if we want to. Okay, logarithms on page number 8 can have any positive base except for 1. So you cannot have a base of 1. That's not allowed. So on page 8, that's just what the first part says at the top. Next, these are the 2 types of bases we can put in our calculator. We're on page 8. Go ahead and turn. Thank you. All right, common logs. That's your other day. The common log has a base of 10, okay? So common logs, your LOG, has a base of 10. But there's another button right below that on your calculator. It says LN. That LN is kind of in a weird order because it stands for natural log, which you would think would be NL. Well, yeah, not really the inverse. It's just a different understood base. Natural logs have an understood base that's a little e. Now, e is a number that's a constant like the number pi. And e is a number that you see on your calculator. You can press second and the LN button, and you'll get that e to come up. So take your calculator for just a second. And I'm going to do it with you. We are going to press the LN button, which is beside the number 4 on this calculator keypad. But we're going to press a second before it. The second button and an LN button. So you get a little e with a caret. Just put a 1 in there. We're going to raise e to the first power. What number do you get? What does your calculator say? 2.71. I'm going to do squiggle equals because it's not exactly that. This is a number like pi that goes on forever and ever and ever. So base e is what your natural log has, the ln. Base 10 is what your common log says. So I want you guys to use your calculator and just type in log of 10 and press enter and write what it equals. Then do log of 1 and press enter and write what it equals. So I just want you to use your calculator for those first 8 buttons, or boxes, I should say, on this page of notes. So if you don't have a calculator, you're going to want to go grab one, please. Yes, Charles? You press second in the natural log button. LN, natural log.
That's how you want us to put the 10 and the 1 and stuff? Or you want to put that with the regular log?
For these, I want you to press the LOG button and type a 10.
All right. Well,
and for these, I want you to...
that, but I didn't know if you want us to do that with the E, or, so you want us to do it with this, not the E?
Right, because that's what it says on here. Yeah.
How do you do the E? Or we're not supposed to be doing that?
You can do those, natural log. So there's an E right above the LN, and there's also an E right above the divide. There's also an E above the divide if you'd rather do second and divide. Just round it to 2 decimal places. So we're using our calculator, Jasmine. Got that one, so write down equals 1, and then do the next one. Uh-huh. So you can either, we're going to have to press the LN button first, and then you can either do second divide. Can you stop? And press enter like that. Or if you do second and natural log, you have to put a little 1 up there. Okay? Damian, this is driving people crazy, so let's put this over here. And you can let go. Thank you. You can get your calculator and do the work that we're doing. Kadian?
How do you do E?
You can do second divide or second natural log. The second button and then the divide button will give you E. And the second button and the natural log button will give you E.
So I do that and then I do that.
Yep. Close your parentheses. Yep. There you go. Make sure we fill in the blank. Okay, for the next column, what do you guys get the natural log of E is equal to? 1.
How do you plug it in?
So you press the LN button, which is right here.
Yeah.
And then you type in E, which is second divide. Close parentheses, enter. Okay? All right. What's the natural log of 1? 0. What's the natural log of 49? Approximately 3.89. Good. And the next one, y'all are already ahead of me. 1.38. I had a 6 after that, so I'm going to round it up to 1.39. Second divide. Second divide is E, everybody. Second divide is E. Okay, so for the this means blank, in blue, I'm going to do what I did in blue over here on the left-hand side. What's the understood base of a natural log? E. Not 10. Common logs are E. Or common logs are 10. Natural logs are E. So E raised to the first power is equal to E is what this one means. So our base is E, our exponent is 1, and it's equal to the E. The base on this one, since it's still a natural log, is still E. What's the exponent on this one, though? 0 is equal to 1. This one, E raised to the 3.89 is equal to 49. And for the last one, what's the base for that one? E is the base. What's the exponent? 1.39 equals about 4. Good. So that's how you use your calculator to evaluate these things. But then it says a couple of lines down here. What do these two logs have in common? Well, one of the things they have in common is that they have buttons on the calculator. So that's probably pretty obvious to you guys, but we're going to actually write that down. What do these two kinds of logs have in common? They have buttons on the calculator. So that's number 1. They have buttons on the calc. The other thing that they have in common that a lot of people forget because they're not written there is that they have understood bases. So they have buttons on the calc and they have understood bases. So one of them has an understood, not written base of 10, and the other one has an understood, not written base of E. So even though they're not written there, you have to know that they are there. The next one, I think somebody asked me about this on Friday, and I said we'll talk about that later. Can we put other bases in the calculator? The answer is yes, but you have to know a formula for that. All right? The formula for this that I'm going to write in this little space over here to the side, let's say I have a base of m, just using a variable there. And I have an n beside it. So log base m of n. If you want to put that in your calculator, if you have a fancy calculator, you may be able to find it under math if you scroll down a little bit. But if you have one of the school calculators, you're going to have to do the log of the big number divided by, just a second, the log of the little number. So log of the big number, which is the n in this problem, divided by log of the little number, which is the little m. So if you want to do other bases in your calculator, log of big divided by log of little. And that's how you can do anything in your calculator you want to. But you got to know that formula. What's up, Diego? You good? All right. So write down that little formula, log base m of n equals the log of the big divided by the log of the little. Good. All right. So let's look at what's right below this and talk about some properties that we can use. These are properties of logarithms with any base. Properties of logarithms with any base. I'm going to fill in these 3, and then I've forgotten Trevor, so I'm going to write Trevor a pass. Okay, the product rule. Product means multiply. So these two are being multiplied together, m times n. what we can do is we can expand these into 2 logarithms instead of 1. So in order to do that, I'm going to write this on the next line down. I'm going to write log base b of m plus log base b of n. That's how you expand 1 logarithm with multiplication in it to 2 logarithms. You put a plus sign in between. Now, division is a little bit different. Right below it, in the box right below, if you have a quotient, which is what this is, what you're going to do is you're going to do log base b of the top thing in the quotient minus log base b of the bottom thing in the quotient. So when it's a product, you're going to add the 2 logs together. When it's a quotient, you're going to divide the 2 logs. If it has a power, which is what you see in the box right below that, if it has a power, what you're going to do is you're going to take the exponent, that n that's in here, you're going to move it out to the front. So you're going to have n times the log base b of m. So these are our 3 properties that we can use to expand logarithms. I want you guys to take a look at the problems that you see beside each of those properties and see if you can expand each of those logs into either a sum or a difference or a multiplied version of a log. And we'll talk about those in just a second. Trevor, I appreciate your patience. Huh? Today it's different from normal. It's too small for me to see. 12:48. Yes? My favorite thing to do is writing bathroom passes. So I really appreciate you guys giving me the opportunity. Yes, Victoria?
How do you do these ones? I don't understand. I can't figure it out.
So you do natural log of e, which is second divide. Enter, and you get 1.
Okay.
Okay? Okay. Over here, log of 10 times x. It's right beside the words for our product rule. So we're going to use our product rule to expand this. Does anybody have any ideas? You don't have to be 100% sure. Katie, you want to try it?
Log 1, 10.
Log what?
Log 1, base 1, then 10 plus log base 1 plus.
Okay, good. So we'd have a log of 10 plus a log of x. Now, Kadian was saying base 1, but what base does this log have? 10. This is an understood base of 10. If we don't write a base, it's always got an understood base of 10. So we don't have to write the base here because it wasn't written to begin with, so it's an understood base of 10 in both of the situations. So log of 10 plus log of x. Who'd like to try the next one? It works the same way with natural logs as it does with regular logs. Yeah, Sabria?
So how do you put natural log? Okay, so I said natural log.
Good.
Then I said e for the base.
Okay. So we can put a little e down there, but you don't have to. It's understood with or without it.
Then
So,
7
okay.
plus log, or not log, but
Natural log?
log.
Yeah.
X.
Good. So natural log of 7 plus natural log of x is how you expand this one. Well done. All right, right below that, we've got some of the quotients happening here. What you got, Colin?
Well, I have a question.
Okay, go ahead.
Why is it plus natural log?
Why is it plus instead of minus?
Like, just why is it like, why do you have to have that?
So why do we change this into this? Right now we're just practicing using this property. So we're just practicing taking a product of things and expanding them into 2 different logs. The reason we're doing this is because tomorrow we're going to learn how to solve equations with these, and these properties are going to help us do that. Okay? All right. So in the one right below it, log of x divided by 2. Brianna?
Log of x minus
Perfect. Log of x minus the log of 2. That's exactly right. Well done. Anybody want to try the natural log of e divided by 7? You got it. Natural log of e minus the natural log of 7. Good. Colin? Ooh, okay. So instead of writing natural log of e, you're suggesting we could just write natural log?
Yes.
All right, look back up at the top. What does natural log of e equal? That equals 1. So while we can't just change it to natural log with nothing beside it, we could rewrite the natural log of e as a 1 if we wanted to. So you could write this as 1 minus the natural log of 7, which is also true. Lexi?
But isn't the E just understood?
Okay, so we're talking about two different e's.
Oh, okay.
Yeah, the understood e is the, yeah, good question. All right, the last one. Now this is right beside the product rule. Let's try the bottom one first. Anybody think they know what to do with the natural log of x squared, Bailey?
You do 2,
Uh-huh.
and then the natural log. And then you said we don't have to put the E. I put the E, but.
Yeah, don't have to put the e, you're right.
And then an M.
And then x, right?
Oh, yeah.
Okay, good. So you can write the e, you don't have to write the e. You won't ever see the e written on a test or quiz, so just know that it's there. So this one works for this one. The top one, though, is a little tricky. Brianna, you want to try it?
Would you take the venus and the square root?
Uh-huh.
Take the x, so it makes it like the 2, so it makes me like 2 log.
Okay. Yeah, so we are going to have a log with an x in it. The question is, what goes in front of it? A 2 would work if it was squared. But how can you write an exponent if it's got a square root instead? Does anybody know how to write a square root as an exponent instead of as a square root? 1/2. All right, so squares and 1/2 are opposites of each other. But if you see a square root, you can rewrite that as a 1/2 for the exponent, and then what should we put out front? We'd have a 1/2 out front. Because with this quotient or the power rule, we're going to take the exponent and slide it out to the front. So now we have the 1/2 exponent out front there. Put your phone up, Anthony. I know that's not an emergency. Okay, so we finished this front page. We're going to flip over and take a look at the back, where you'll see we're applying all of these different things all together in one big group. So you'll see power rules mixed with quotient rules mixed with product rules. Once you get the hang of this, it's going to be really quick for you. So when you do your homework, which is on page 11, it shouldn't be too bad. In this first one, the log base 5 of x squared times y cubed. Which two rules do you guys think we're going to need to use there? I'm going to need to add some, right? And then what else? I've also got the power rule. So you have options. You can do this in two different steps. You can do log base 5 of x squared plus log base 5 of y cubed, because those were multiplied, and multiplied changes into addition. But then we still have to take care of those exponents. So if you wanted to, if you're really good at the rules, you could do all of this in one step. I'm going to scoot my exponents out to the front and do 2 log base 5 of x plus 3 log base 5 of y. And that's as good as I can go. Once I don't have anything multiplied inside of my log, I don't have any exponents, I don't have any division, that's the end of the road. So the yellow answer up there is my answer for the first box. In the second box, first, if you wanted to, you could do log base 6 of 36 plus log base 6 of x squared. So that would be your first step. But I'm not done, because what else can I do to that problem? The power rule. So I have an exponent right here on the x, and I got to kick that back to the front. So my final answer, I'm not going to do anything to change the first one. Log base 6 of 36 plus 2 times log base 6 of x. So again, you don't have to write the blue step down if you don't want to. You can jump straight to the pink one if you want, because the pink one is our goal. And as long as you have the pink, you're good. In the next one, notice how I have a natural log instead of a regular log. I don't have to write the base of e unless I really want to. This one's going to be super duper long. Do you guys see any powers in there? No, no powers. So we're just going to have to use the product and the quotient rule. Here's how this one's going to look. I'm going to write down the answer, and then I want you guys to see if you can figure out why that's the answer. That's a 6 to match the 6 in the original question for the base. This is a 6 to match the 6 in the original question as the base of the log. Okay, so here, I'm going to draw a little line so I don't get these mixed up. I'm going to have to write this on a couple lines. I'm going to have the natural log of 2 plus the natural log of r plus the natural log of s. So natural log of 2 plus natural log of r plus natural log of s. Does everybody see where that's coming from so far? All right, so all that's multiplied together. Here's where people get confused. When we have that division down there, see how the 5 and w are multiplied together? So a lot of times people think that we're going to do a minus the natural log of 5, which is correct, and then they put a plus natural log of w. But the key to these is that if anything's in the denominator, you better have a minus sign in front of it. So since the 5 and the w were in the denominator, we're going to have a minus sign in front of both of those natural logs. Yes, ma'am?
What's the stroller?
In the next one, did you guys, those of you who are trying, get log of x minus the log of y minus the log of z? Y'all got that? Good. If it's in the denominator, it better have a minus sign in front of the log. One thing that I do is I write the L's in cursive so they don't look like ones. That's not a requirement. That's just what I started doing. Victoria?
Is that all one thing or is it like under?
It's all supposed to all be on one line, but since these boxes are so skinny, even when I wrote it on paper, I couldn't get all this on one line for some of them. Okay? In the next one, you could do this in a couple steps, but here's what you get for your final step. You should have the log of 2 plus 3 times the log of x minus the log of z. And I draw lines through my z's just so they don't look like 2's, because my 2's and my z's look the same otherwise. Head up, Diego.
I don't understand why we put the numbers in front of the log.
Numbers go in front of the log anytime you have exponents. So this 3 came from that exponent right there. Okay, so that's your power rule. Okay? In the next one, this is one a lot of people miss as well. That's squared. Which of these things does it go with? All of them. It goes with the 3, it goes with the x, it goes with the y, it goes with the z. So when we're finished with this problem, we should have a 2 times the natural log of 3 plus a 2 times the natural log of x plus a 2 times the natural log of y plus a 2 times the natural log of z. So there's a 2 in front of all of those because there was an exponent of 2 on all of them. So anything that has an exponent is going to have a coefficient out front. Colin? So that's a good question. One option that Colin's talking about right now, instead of writing this as 2 times the natural log of 3, I could write this as the natural log of 9. Does everybody see where that's coming from? 3 squared is 9, and 2 times the natural log of 3 is equal to the natural log of 9. So you could write it like that. You would write the 9 behind it, yes. All right? Okay. So, all right. So, that's how you do those first ones. Let's look at the ones right below this. Any questions on this before I switch the slide? Okay, here we go. Last slide.
Can you go back for a second?
Danya.
Oh, it's okay, it's okay. Keep going.
Okay. Just ask me before I switch the slide. Okay. All right. In this set, notice that we're working backwards. So now we have the expanded version, and we've got to condense it down to be just one log. Whether it's got a base of 6 or 10 or e, we've got to get just one log instead of lots of them. Who thinks they know what to do with that first one up at the top? Brianna, what you got? Good. Log base 2 of x times z. So we're taking addition and we're mushing it down into a product. All right? Bailey? You got the next one, or are you just...
Oh, yeah, I did.
Okay. What you got?
Log base 3, x squared y cubed.
Log base 3 of x squared times y cubed. Very, very close. One thing we need to change. Naya, you're right. We need to make this division because of what? Because we had subtraction in there.
So it'll always be division versus subtraction.
Yep, if you see a minus sign in front of the logarithm, that's going to go on the bottom of the fraction. All right? In the one right next to it, finishing up that top row. Log base 2 of x to the 4th and y what? Y to the 5th. Good job. Okay. The next row gets a little bit trickier, but you guys may remember seeing one of these on our front page. This is going to be an exponent of 1/2. So we've got a log base x raised to the 1/2 power, which is the same thing as what? The square root of x. So I'm going to write it two different ways. I can write as log base 10 of x to the 1/2 plus, or sorry, my bad, times, because I'm working in reverse now, 2y raised to the 1/4. Well, it's very important that you put that 2y in parentheses if you're using fraction exponents, because the 1/4 goes with both of those. So that's one way to write it. Like Victoria just said, 1/2 as an exponent is the same thing as a square root. So I could write this as the square root of x. And then what would 1/4 be? A 4 on the outside. So a little index of 4 with the 2 and the y inside. So these two things are the same. It's just a different way to write it. So you may see it one way on the test, you may see it the other way on the test. So you just got to know both ways, just in case. Yes?
Is there going to be only one way, or like which one do you recommend knowing?
Well, if it was multiple choice, you might see it written either one of these ways. If it was short answer, you could choose either one that you wanted.
What if it's multiple choice, you just choose one?
It's not going to be written both ways, only one or the other.
Oh,
Okay? All right, so I want you guys to take just a second. Hold on. Just a second to finish up those last 5 boxes. What was the question over here? Okay, Damian? This one?
Yeah.
What's up?
But before we separated the like twos and the other ones like went like from above, we separated.
The 2 and the y?
Yeah.
Okay, so the difference here is that we want to combine them into one thing instead of two things. So if we were trying to expand this, you're right, we would write it as a log of 2 plus a log of y. But now we're trying to condense it into something smaller.
Since normally we would have
Are you saying, could I write this as a y plus y?
yeah.
You could do that, but it's not necessary. Okay, so finish up those last 5, and then your homework for tonight is page 11. Real quick, just going over these before you guys get your homework done. Y'all should have log base x, or log base 10 x squared. Then we have 3y cubed, and all over w to the 4th. Now, if you want to write it like this, make sure you put the 3y in parentheses. Or if you wanted to, you could say, well, 3 cubed is 27. You could do 27y cubed instead if you want to. But you got to have those parentheses or it is wrong. In the next one, there's a couple ways to do it. The 3 that's out there right now is just 3 times 5. So you could rewrite this as 15 log of x cubed first if you wanted to. That's what it means when it's multiplied like that. And then you can take that 15 and make it into a power. So what do you get when you have log of x cubed raised to the 15th power? What's that the same thing as? 15 times 3 gives us 45. So all of that is equal to the log of x to the 45th power. And that's probably how you would see the final answer written. Down here at the bottom, we have log of 2 to the 5th. Whoops, that was written wrong. 2 to the 5th and 2 cubed. But I can definitely simplify that. 2 to the 5th and 2 cubed is the same thing as 2 to the 8th. And 2 to the 8th, if I multiply 2 times itself 8 times, 2 times 2 times...
Would it be wrong if we don't simplify it out that far? Like all quizzes?
We want to simplify as much as we can. You won't get a lot of points off for not doing that last step. Maybe if it's like 10 points, you get 1 point off. But if you can do that, go ahead and do it. 2 to the 8th power I can do in my calculator. It's going to be a big number. I'm thinking like 256.
Yeah, why wouldn't it be 4? Like 2 times 2 and then add your
Why wouldn't 2 to the 8th be 4?
No, why wouldn't you do like how you added your exponents?
Oh. Yeah, so if you have the same base, you're going to add your exponents, but we don't add the bases. All right. On the next one, if we distribute this 1/2, we get 1/2 natural log of x minus 1/2 natural log of y. Then if we change that into one logarithm, we've got the natural log of the square root of x divided by the square root of y. Because of that minus sign, the square root of y is going to be in the denominator, and the 1/2s are what we get the square root from. And finally, we have the natural log of 7 over 3 times 6. Did y'all catch that? The 6 has a plus in front of it, so it's got to be up top. 7 times 6 is 42, and 42 divided by 3, I think, is it 14? Can you divide 42 by 3? Yeah, you get 14. So this would be your final answer that's the most simplified. All right?